Okay, guys, we have come to the last subtopic in your chapter 6. The last subtopic is model selection. So, in model selection, what is our objective? Our objective is actually we want to have the model with less predictor. Okay, means that less x. Okay, because of multiple linear regression, we have more than one x, right? So with model selection, our objective is we want to have a model with less predictor, with the significant predictors only. So there are procedures to do the model selection. We want to select the best model, right? So we have the procedure. So let's look at here. In model selection, we will perform the regression analysis for all 2 to the power of k minus 1 possible models using Excel. K is the number of your independent variable. So let's say you have x1, x2. So your k is equals to 2. Right. So let's look at here. If there are k independent variables, for example, x1, x2 up to xk, there will be a total of 2 to the power of k minus 1 possible models. So it's actually like this. Okay. You have 1y and then you have 3 independent variables. x1, x2 and x3. Y depends on x1, x2 and x3. So, how many possible models that you can have? Possible model, there is equation 2 to the power of k minus 1. So, here we have x1, x2 and x3. So, k is equals to 3. So, how much possible models we have if we have k equals to 3? So, 2 to the power of 3 minus 1 equals to 7. So, we have 7 possible model. Y depends on x1. Y depends on x1, x2. Y depends on x1, x3. Y depends on x2. Y depends on x3. And y depends on 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1 depends on x2 and x3. And the last one, y depends on x1, x2, x3. So, this is what we call it as 7 possible model. 1, 2, 3, 4, 5, 6, 7. 7 possible model. So, the possible models is depends on the number of independent variables that you have. So let's look at the procedure to do the model selection. First, summarize. First, you need to find the possible model. So the number 1 just now is find possible model, where the formula is 2 to the power of k minus 1. Step number 2, summarize all the possible model in the Excel output in a table. So for step number 2, you need to build a table. So your table must have the first column predictor variable, which is your x. Second column is the p-value. Where can we take the p-value? From the Excel output. Third column is r square, also from the Excel output. And the third column is adjusted r square, your coefficient of determination, also from the Excel output. And last is your regression equation, also from your Excel output. So I repeat again, first step, you need to find your possible model. And after that, you have to summarize all the possible models in a table, where your table you must have this column: predictor variable, p-value, r square, adjusted r square, and regression equation. And step number 3, we choose the best model. How we want to choose the best model? Look at the smallest p-value and highest r square for one predictor variable, which is x1, x2, x3. Find smallest p-value and highest adjusted r-square for two or more predictor variables. x1, x2, x2, x3, x1, x3. Okay, so don't worry. Look at this example. Please understand this example. Okay. Example 6.2b. So this one is the case study, the same for 6.6b. Okay, a house builder wants to determine the favorite type of houses that will attract residents of the community. A multiple linear regression analysis was performed to investigate the relationship between sales price for the houses based on square feet, number of room and number of bedroom. So you have here the result of Excel output is illustrated in figure 3 until figure 9. So from here, procedure for model selection. Number 1 is calculate the possible models. So how to calculate the possible models? Okay, perform regression analysis. How to calculate the possible models? We have square feet, room and bedroom. So we have 3x. So k is equals to 3. So 2 to the power of k minus 1. 2 to the power of 3 minus 1 equals to 7. So there are 7 possible models. So what are the 7 possible models? S, R, B, SR, SB, RB, SR, B. Y is related to S, R, B. Y related to SR, Y related to SB, Y related to RB, and Y related to SRB. So we can assume that X1 is S, X2 is R, X3 is B. SR, X1, X2, SB, X1, X3, RB, X2, X3, and SRB is X1, X2, X3. So there are 7 possible models. Step number 2. What is step number 2? We have to put into the table. There you go. You will have first summary output for variable S. X1 only. Okay. Here is your R square because of only one X. Here is your adjusted R square. Here is the p-value. Here is the equation. Beta naught cap, beta 1 cap. Put it into this table. Okay, so let's get one by one. Predictor x1, which is S. R square here, 0.6332. Adjusted R square is here, 0.6272. P-value here, 0.0000. And the equation is from here. Y cap is equals to negative 3.7210 plus 0.0548 x1. Done for predictors x1. Next, we have to find for x2. How do we find for x2? Look at the next Excel output. Next Excel output is for R. R here is x2. Okay, so x2, the R square is 0.3514. Adjusted R square here 0.3408. P-value here 0.0000. Equation here is beta naught, here is beta 1. Y cap equals to negative 4.0652 plus 13.2840 x2. Okay, next find for x3. Look at the next Excel output. B is x3. Okay, so we put here R square 0.2808, adjusted R square 0.2691, p-value 0.0000, and the equation here is beta naught, here is beta 1. So y cap equals to negative 1.512 plus 27.2031 x3. Okay, next find for x1, x2. So this is the Excel output, x1, x2. So put it into the table, R square here, adjusted R square, p-value, and the equation. Here is beta naught, beta 1, beta 2. Okay, you will have x1 and x2. Okay, next, x1 and x3. So S is your x1, B is your x3. So put in the table, R square 0.6445, adjusted R square here 0.6326, p-value 0.0000, and here is beta naught, beta 1, and beta 2. You will have x1 and x3. Next, x2 and x3. You will have here x2, x3. Okay, R square 0.3702, adjusted R square, p-value, and the equation here is beta naught, beta 1, beta 2. So you have x2 and x3. Last one, x1, x2, x3. x1, x2, x3. So R square 0.6525, adjusted R square here, and the p-value, and here is beta naught, beta 1, beta 2, beta 3. So you have x1, x2, x3. Done. Complete our table here. Okay, and then we copy our table here. Okay, so this is our table just now that we create from the Excel output. We want to find the best model. So the step is we have to find the smallest p-value and the highest coefficient of determination. So let's look at first step. We have to eliminate this one because why? We want to find the best model with less predictor. This one is the most predictor, x1, x2, x3. So we have to discard this one. Okay, next, find the smallest p-value. If you look at here, all the p-value is 0, less than 0.05. So all the predictor is significant. Next, we have to look at the highest coefficient of determination. Okay, for x1, we take this R square because of simple linear regression. x2, this one, and x3, this one. For multiple linear regression, x1, x2, we look at the adjusted R square. x1, x3, adjusted R square. x2, x3, also adjusted R square. So from this 1, 2, 3, 4, 5, 6, find the highest coefficient of determination. So the highest coefficient of determination, so the answer is the best model is x1. Why? Because of the highest coefficient of determination. Look at here, 0.3 is smallest, 0.3 is smallest, 0.2 is also smallest. 0.63, okay, here is smallest, 0.62. 0.6326, 0.6332, which one is the highest? This one. Okay, so the best model is y cap equals to negative 3.7210 plus 0.0548x1. This one is the best model. Why? Because x1 has the smallest p-value and highest coefficient of determination. Okay? So that's all for example 6.2b. So let's look at how to solve exercise 6.7.